All right, everybody, let's talk about a new thing, the vector cross product. We've already talked about a dot product, but the vector cross product is most important in three-dimensional space. We can do it in 2 dimensions, sort of, but you really need to do it in 3 dimensions. So let's say I have 2 vectors. I'm going to stick with the one that I had last time. This is the white vector, so I'll call that W. And this one kind of has a red color to it. Let me get my red vest out from behind it. So we'll call that R for red. And what I want to do is I want to take the vector cross product of W crossed with R. Now, the first thing I want to do is I want to say that when I do a vector cross product, I get a vector. The result is not a scalar quantity. It's not a number. It's a vector. So it's magnitudes, directions, the whole 9 yards. And it's going to be in 3 dimensions. This obeys the right-hand rule. So if I do W cross R, W, put my fingers in the direction of W, rotate my right hand in the direction of R, and my thumb points in the direction of the resultant of those two, which will be a P, because I have a purple string here, right? And so the way this works is the P string is perpendicular to both the W and the R, the white and the red. So the purple string, that shows up as purple, is perpendicular, mutually perpendicular to W and R. If I alter the angle here, I've got to alter this here, okay? And so I've changed the direction of, by changing the direction of red, I've changed the direction of purple. So the purple string is perpendicular to both W and R, the white and the red. There is a relationship between the magnitudes that I'll get to, and I'll do more of this in detail later. There's an angle between these 2 strings. And if I take this flat board and I put this here, you can see that there's an angle in between the white string and the red string. It might be a little hard to see because this has a white background. But there's an angle between the white string and the red string. Okay, and let me just drop that a little bit. And so you'll see this angle in here. And we're going to call that angle theta. Doesn't matter how I do this. I can move this over. There's always going to be some angle in between these 2 vectors, even if it's more than more than 90 degrees. Right? So I can have 2 vectors here. Put it out here a little bit. There's an angle between those, and it might be more than 90 degrees, and we'll talk about that in more detail here in a little bit. But there'll always be, let me do that this way, there'll always be another vector that is mutually perpendicular to both of those. So W cross R, right-hand rule, W cross R points out this way. If I do R cross W, I'm not going to be able to get my hand to do that, R cross W, it points in the other direction. So it would be pointing 180 degrees opposite of this purple string, so somewhere on the back side, which I'm not going to show you because it would be in the way. Actually, I could. So let me just move it. It's going to be pointing this way. So R cross W points back away from the camera towards the board, right? And so the idea here is the cross product of 2 vectors is a third vector that is mutually perpendicular. That is to say, perpendicular to W and perpendicular to R. Mutually perpendicular to the 2 vectors that created it. So another thing that means then is that if W and R are collinear, so the angle between them is 0 degrees or 180 degrees, I can pick an infinite number of purple vectors that would be perpendicular to both of them. And the reason that happens is if 2 vectors are parallel or anti-parallel, 180 degrees off, the cross product is 0. There is no answer, right? And if you think about it, that's because there's an infinite number of possibilities, so there can be no answer. All right, so there's a brief introduction to the whole concept of the vector cross product. Super important, the vector cross product. So the cross product of 2 vectors creates a third vector, and that vector is perpendicular to both of the 2 vectors that created it. So the purple vector is perpendicular to W and is perpendicular to R. Okay, so it's going to be perpendicular to both of them, always. And then there's always going to be an angle in between two vectors. I can go down here, and there's an angle in between those two. Okay, the way it's oriented will determine how I have to change this plate, right? But there'll always be an angle in between those two. And that angle I'm going to call theta, and we'll get into more mathematical detail on that in the next video. All right, if you have any questions, please put them in the comments below.